Okay, today's lesson is going to sort of build off of the adding, subtracting, and now we're going to be doing multiplying and dividing rational equations. Now, normally we would do this before adding and subtracting because it involves a lot of the same things. But because I knew I was going to be gone on Friday, or today if you're watching this, I knew that this would be an easier lesson to do a video note. So with me not being there, this would be something easier to get. But basically, multiplying and dividing is a lot easier because there is no need to find a common denominator. So unlike addition and subtraction, where you had to make sure that the denominators were the same, with multiplication, it actually doesn't matter what the denominators are. You can go right to your factoring and then canceling things out. So it makes it a lot easier. So to practice with factoring, we're going to do a couple of these problems here to review our factoring techniques. So let's look at number one here. In order to simplify rational functions and irrational equations, a lot of times we're going to need to look at these problems and factor quadratics here. So what you're really looking at is what multiplies to be -9 and adds to be -10. What multiplies to be -9, or sorry, multiplies to be 9 and adds to be -10 is -9 and -1. So it's x minus 9 and x minus 1. And that's the basic factoring. So we can do this one too. And this is m's, so we kind of have to be careful here and make sure that they're m's. What multiplies to be, -24 and add to be 2? A lot of things multiply to be 24, but in this case, what works is a +6 and -4. And that would be factoring, basic factoring. So as long as we understand these skills, we can be fine. And they do get a little bit more complicated. Number 4, if we go down here, number 4, this is a difference of squares. So the way we do difference of squares, remember, is, oops, let's go back on that. Got a little ahead of myself. What we do here is with different squares is one's a plus and one's a minus, and all you do is simply square root each term. The square root of 16 x squared is 4x, so we put 4x in the front part, and the square root of 9 is 3. And that's difference of squares. Sometimes it's not factoring a quadratic or factoring at all, really. Like in this case here, sometimes it's just taking out a GCF. And so sometimes you can look at it and go, hey, wait a minute, I see some things that I can divide out. And so sometimes you can, like in this, you can divide out a 2 and an x. We take out a 2 and an x, and you're left with just x minus 4. And that's all you do. There's not really any factoring needed. So that's factoring. I wanted to just to review that because you're going to see it a lot in today's lesson. So in order to simplify rational expressions, you want to check for factoring first. Okay, simplifying rational expressions, you want to factor and then cancel if you can. So the whole reason why you factor is to see if there's any common factors on the top and the bottom that can cancel each other out. So what you want to do first, look for factoring. If you can factor, whether that's taking out a GCF or doing difference of squares or whatever, but factor first and then see if anything cancels. So when we look at number 1, this is a rational function. Now, in this case, there's no factoring that needs to be done, so I can go right ahead to start canceling things if things cancel out. Now, the numbers, okay, these numbers here don't necessarily cancel out, but I can reduce them. There is a fraction there that can be reduced. 32 over 24 is, I believe, 8, 16, 20, 4 over 3, I believe. 4 over 3. And then the n's will cancel. So there's one n on the bottom. This one n is going to cancel with one of the n's on top, making it just n to the first on top, or just n. And that's simplifying rational expressions. That's obviously as easy as it gets, but that's that. So here in B is a case where I would need to factor first. So again, you want to factor if you can first and then see if anything cancels. So if we factor this bottom half here, again, you're looking for what multiplies to be this C and adds to be the B. So what multiplies to be negative 6 and adds to be 5? Well, if you think about it, what multiplies to be 6 or negative 6 and adds to be 5 is positive 6 and negative 1. So again, and the whole reason why you do this is because you look for common factors. I see up here and down here I have common factors that I can cancel out. So what this leaves me with is fraction line and just x minus 1 on the bottom. Now, just like we've discussed this in the past, you can't have nothing on the top, so we put a 1. And that's it. That's simplifying rational expressions. Okay. Why don't you, no, let's see. We'll do this one together. It's a little bit more complicated. So on the top here, we got a couple things going on the top. One thing that you should notice is that they do all have an x. So the first thing I'm going to want to do before I do anything out is take a GCF out. So let's take out an x first. And that leaves me with x squared minus x minus 42. And on the bottom, I do have a GCF as well. I do have a 2 that can be taken out. And that gives me x squared minus 10x plus 21. Now, with what I have left over, is also factorable. So this top one is factorable, and this bottom one is factorable. So we'll start with the top. What multiplies to be 42 and negative 42 and adds to be negative 1? It might take a while, you might have to think about it a little bit, but actually what multiplies to be negative 42 and adds to be negative 1 is 7 and 6. Well, negative 7 and 6. So it's negative 7 and plus 6. Now we do the bottom, see if there's anything that cancels out. On the bottom, what multiplies to be 21 and adds to be negative 10, okay, 21 and negative 10 is negative 7 and negative 3. And what you see, again, just like in previous problems, is you have common factors on the top and the bottom that do cancel out. And so what I'm left with is what's left over here. I do have an x here, and then I do have this. So what this looks like, let me sort of zoom out here. On the top is I have x, and then x plus 6. And on the bottom, I have this 2 and the x minus 3. So 2 and x minus 3. And that now is completely simplified. So that's simplifying rational expressions. So now we move on to multiplying and dividing. Now multiplying and dividing is the exact same thing. They're just on a little bit of a grander scale. So if you want, you can go ahead and try some of these extra problems if you want to. Like, why don't you go ahead, pause the video, and try to do E here on your own, and then play the video when you'd like to see the answer. So there's the answer to that problem. The top factor to b minus 7 and b plus 4. And actually, you know what? I got that wrong. It should be b plus 7 and b minus 4. And actually, the b plus 7 should have canceled. So it should be b minus 4 and b minus 7. B minus 4 over B minus 7. The bottom factors of difference of squares factor to b plus 7 and b minus 7, and then the b plus 7 is canceled, leaving us with b minus 4 over b minus 7. So what you're going to see when we get into multiplication, as we go onto the next page, is you're doing essentially the same thing. So here's an example, a multiplication. So what's nice, again, about multiplication is I don't have to worry about whether or not the denominators are common. I can go right into factoring and canceling. So there's a couple ways to go about this. With number one, there is no factoring. I don't have any quadratics or anything like that. There's a couple ways to do this. You could just multiply this times this, and this times this, and this times this, and this times this to get sort of one super fraction. Or what I like to do is sort of skip that and make a super fraction this way. Now that they're all sort of on the same line, now I can cancel and reduce as I please. So, for example, I have a 4 on the top. That'll cancel with the 4 on the bottom. Okay. I have three x's on top will cancel with 3 of my x's from the bottom, which makes that x squared. I have 3/21. This right here is a fraction that will reduce. 3 over 21 is 1 over 7. And now 14 over 7 I can reduce to 2 over 1. And so what you end up writing is just sort of what's left over. On the top, all I have on the top is this 1 and that 2. That's it. Everything else is crossed out. 1 times 2 is 2. On the bottom, all I have is this x squared, this 1, and this x squared. So it's x squared times 1 times x squared, which is x to the 4th. And that's your answer. So it's important, if you're going to do it that way, that you sort of keep track of everything, cross things out as they cancel, and rewrite things below. If that makes sense to do it that way, you can certainly do it that way, or you can just multiply everything straight across into what's some sort of like super fraction, and that works perfectly fine too. So an example, I'll show you an example of that. Let's see if I have it. I don't actually have one on this page. We'll do one later. So now number 2, you'll see that I do need to factor first. So what you're going to do is you're going to factor all the things that can be factored and then cancel out things that need to be canceled. So I'm going to make this a giant sort of super fraction here. And I'm going to factor all the things that I know that I can factor. So it's all of these. I don't care that they have common denominators or not. Okay, and now I'm going to fill this in. So the top right, what multiplies to be -6 and adds to be 1 is x plus 3 and x minus 2. Bottom right, what multiplies to be -3 and adds to be -2 is x minus 3 and x plus 1. And then the bottom left, what multiplies to be -3 and adds to be 2 is x plus 3 and x minus 1. And now I can freely sort of cancel things out that need to be canceled. So first off, I have an x plus 1 that will cancel out with the x plus 1 down here. They do need to be on opposite sides of the fraction. They can't be on the same side. I have an x plus 3 that'll cancel with an x plus 3. And that looks like that's it as far as common factors that can be canceled. So on top, all I have is the x minus 2. And the bottom, I have x minus 1 and x minus 3. And that's it. That's completely simplified. If you'd like to make the bottom a quadratic by foiling, you can, but that's the same thing. So that's multiplication, pretty simple. Just multiplying straight across, and factoring. If you remember, just to factor first and then cancel if you can. Now division. Division is really easy too. You would think that division would be something different, but if you remember back to grade school, when you go to divide fractions, like if I did, 1/2 divided by, 3/4, your teacher always said, well, don't divide 1/2 by 3/4, just multiply by its reciprocal. So instead of dividing by 3/4, your teacher told you, just multiply by its reciprocal. Flip the fraction around and now it's multiplication. So what we can do is essentially with the division problems is just change them to multiplication, and it's the exact same thing we did before. So I can change this. Let's flip this around. So I'm going to put the x squared minus 4 on the top and the x squared minus 3x minus 4 on the bottom. And so we don't get confused. Let's cross that out so we don't, that doesn't influence us in any way. And now this is a giant multiplication problem. And I just go about solving it the way I did before and factoring wherever possible. Now the one thing that we haven't seen before until now is something like this, where it's x minus 2 squared. But if you remember when we did this before, earlier in the semester, x minus 2 squared just simply means that there's two of them. X minus 2 and x minus 2. Okay, that's not there anymore now. And then we factor. On the top right, we have a difference of squares. So this is x plus 2 and x minus 2. The bottom right here is going to factor what multiplies to be negative 4 and adds to be negative 3 is x minus 4 and x plus 1. And we go about canceling things wherever we can. So I do have an x minus 2. That's going to cancel with an x minus 2 on the top. I have an x minus 4. That'll cancel with an x minus 4 on the bottom. And now that looks like that's really all I can do. So my solution, the only thing that's on top is the x plus 2. And on the bottom I have an x minus 2 and an x plus 1. So really, in summary, division and multiplication are the same thing. You just have to remember that in division you have to flip the fraction and change it to multiplication. Now sometimes they look all weird and funny. Like they'll look like number 2 here. It's the same thing. You got, this looks crazy. But basically you have x plus 2 squared over x minus 3 divided by x squared minus 4 divided by x minus 3. So if we just sort of, move this over here, what this really is saying is this divided by the x squared minus 4 over x minus 3 squared. That's this whole part here. Okay, get rid of that. And you would go about your business. You would flip this around and factor wherever possible and cancel anything out. So that's really it. That's multiplication, and that's division. Sometimes the problems will just require you to take out a GCF. Like if we go down here to the extra practice, number 1, sometimes you can just take out a GCF, and that's really all you need to simplify. So on the top, I can take out a 2 and an x squared. So if I take out a 2 and an x squared, that leaves me with x minus 4. So I factored out a GCF, and now I have some things that I can cancel. I have an x squared that I can cancel with an x squared on the bottom, and the 2 over 6 reduces to 1/3. So 1 over 3 and x minus 4. And that's it. So sometimes they're that easy. So like number 2 is the same thing. You would take out a GCF. So like number 2, the GCF There's no number that goes into 5 and 2, so I would have to take out x's or y's. The most x's I can take out is 1, the most y's I can take out is 2 of them. So when I take out an x and 2 y's, I'm left with 5y minus 2x. When I take out, that's just taking out a GCF. And then I have the x squared and the y squared on the bottom, and I can go about canceling common factors like the y squared. Now, one of my x's on the top will cancel with one of my x's on the bottom, so it's just x to the first. So what this simplifies to on top is the 5y minus 2x over x. Okay. So what you have here, I want you to take some time. We're going to go to the next page here. I want you to take your time going through some of these problems here and practicing some of the work. Let's look at, we'll do the odds. Tell you what, I'll do the odds. So go ahead and try 5, 7, and 9, or try 5. I'm gonna go ahead and pause the video here, and then I'm gonna do number 5, and then you can do it on your own and see if you get the correct answer. So whenever you're ready with the answer to number 5, go ahead and hit play. Okay, so again, with multiplication, we can just sort of create this sort of super fraction here. And since there's no factoring that needs to be done, I can go right to canceling things. Okay, I have a y here that's going to cancel with one of my y's here, so this is now just y to the first. But now the y that's on top here cancels with the y that's down here. The x that's right here will cancel with the x that's down here. And that looks like that's all the canceling I can do. So all that's left is a 3 over a 2x. That's it. That's multiplication. Okay, go ahead and try number 7 on your own. And when you're ready with the answer, go ahead and hit play. Don't forget that with division, you do have to flip the fraction, change to multiplication. Okay. Okay, so what I'm going to do here is I'm going to flip this fraction. So I'm going to place the x minus 6 over on the top and the x minus 9 on top. And on the bottom, the x plus 1 and the x minus 6 here. This is no longer needed. Okay, I don't want it to distract me, so I'm going to cross it out just so I don't use it. This is now multiplication, and now I can go about canceling things. So I have an x plus 1, that'll cancel with an x plus 1 there. I have an x minus 6, that'll cancel with an x minus 6 there. And that looks like that's all that I can do. So what's left here on the top side of the fraction is the lone x over here and my x minus 9. And on the bottom, I'm left with just an x minus 2. And that is it. The last question that we're going to do here together is this one here. So again, go ahead and pause the video, try the problem on your own, and then return to the video when you are ready. Okay, since this is multiplication, I don't have to worry about flipping anything, but I'm going to factor things whenever possible here first. So I noticed that there's no quadratics necessarily that I can factor, but I do have some things that I can take GCFs of. So the bottom one here, I can take a GCF, and that makes that x and then x minus 2. So I don't need this anymore. The bottom right here gives me x, and then that gives me x squared minus 4, which in turn is actually a difference of squares, so this factors even further to x plus 2 and x minus 2 so I don't need that anymore. And the top right, remember these? This is actually a sum of cubes. And you might have to refer back to your notes to remember the formula. That is a sum of cubes. X cubed and 8 is a cube. So sum of cubes, the answer to that sum of cubes is that is x plus 2, and then you get x squared minus 2x plus 4. So then now I can go ahead and start canceling things out. So I do have an x minus 2 that'll cancel with the x minus 2 there. I have an x plus 2 that'll cancel with the x plus 2 there. And that looks like that's all I can do. I forgot that I don't need that anymore. So what I have now, and this is absolutely as hard as it would get. I don't even think on any quiz or test you even have a sum or difference of cubes, but this just shows that it works with any factoring. On the top, I do have the lone x over there, and then the x squared minus, minus 2x plus 4. And on the bottom, I have I forgot something. A lone x and an x plus 7. Actually, the lone x's can cancel. So my answer actually is just this part here. That's it. That's multiplying and dividing. So in summary, when multiplying, so when we look at a problem like this, when multiplying, you want to factor if possible first. Factor, that's a difference of squares. Factor, and then cancel out. You can create some sort of super fraction here if you want to. Factor out. Once you factor, everything's factored, whether it's a GCF factor, a difference of squares factor, or just a regular quadratic factor, you can then cancel things out. And that's multiplication. With division, okay, you just have to remember that the fraction needs to be flipped around, and then you can change this to multiplication and cancel things out, just like you did with multiplication. That's it. Your assignment is in Big Ideas. I believe there's only 6, 7 questions in there. That's your assignment. And I'll be handing out G-Bucks when we can't come back to class for both the previous assignment and this assignment today. So that's it. If you have any questions, please do not hesitate to come into AL on Monday. Since I'm not there, I want to make sure everybody still understands it. So if you need some help, Monday I will not have a class in AL. So you're more than welcome to come in there and get any help with this, or just send me a message on Canvas. Thanks.